Hello there, welcome to another Outcrop video. Today we're going to be talking about what is CCS and why we need it. And this is a really important subject that I want to raise awareness for. I am not an expert by any means, but this is what I know. This is an introduction. CCS stands for carbon capture and storage. It is a really key technology for our generation for this time. And why we need it is ultimately because of climate change. This is a graph showing global energy consumption, and it's ramped up massively. As you can see, this graph just goes to 2018. The red at the bottom, burning wood and stuff, this is fairly sustainable. Above that in the grey you have coal. This is a massive chunk of the energy pie globally, and it is the worst fuel, being the most polluting source that we're using. Above that is crude oil in the blue, which is better than coal, but still not great. Above that is natural gas, which again is better, but not ideal. And then we have all the renewables, making just those tiny little striped contributions to the top. I tried to find similar graphics for the UK. All I could get was this table. And so I've quickly made this into an Excel table just to show a real rough graphic of the UK. And you can see the UK has done all right since 2011 to 2018. It has reduced its coal from around 30%, which is really good. And renewables are on up. This is the right trend. We need that to be the same globally, and we need basically to continue that. As I'm sure you have heard, there is this thing called climate change, specifically anthropogenic climate change, which is basically science is saying that because of the CO2 that we've released into the atmosphere, primarily from burning fossil fuels, we have managed to increase the global temperature by about 1 degree. And this is set to continue with the more CO2 that we produce. This has negative effects on the environment, and so the aim is to reduce our CO2 output and in fact start allowing the Earth to reabsorb its CO2. And this is where carbon capture and storage comes into the picture. And so you saw the energy consumption on a global level, how it was broken out, those different things, just that tiny bit the top of the graph that was from renewable energy, and that needs to increase obviously. At the rate that renewable energy is increasing, it's going to take a long time before that is the major energy source, and so that's where carbon capture and storage comes in. Carbon capture and storage is basically what it says on the tin. It is storing carbon underground, storing it so that it doesn't go into the atmosphere. And there are many different technologies and applications for CCS, but we're going to focus on those relating to fossil fuels. As we've seen that the fossil fuels we're going to be reliant on for a considerable time until renewable energy sources grow in their capacity, and that is why CCS is so necessary now, because we are still reliant on fossil fuels and we are going to be for some time. Currently, as we produce energy from fossil fuels, CO2 is released into the atmosphere. We can instead pump it underground into geological storage sites where the CO2 will be stored over geological time periods. And so how geologists find CO2 storage locations is very similar to how you find fields in oil and gas. You're looking for a reservoir rock that is porous and permeable to be able to hold and contain the CO2, and you're looking for a structure that keeps it all in one place, and it needs to be sealed. So you need a rock that the CO2 can't flow through. This is quite a key part, and where study is currently ongoing, because methane, which is natural gas found underground, can be sealed by carbonate muds and seals, shales, etc. Whereas CO2 is a slightly different beast. CO2 is a smaller molecule, so it requires a better seal, And also it attacks carbonate, and so limestones and lime muds, etc. in the system will be attacked by the molecule and will not be an adequate seal like they are in the case, or like they can be in the case of searching for natural gas. And so there's quite a few projects that are already ongoing. Lots of projects have already happened worldwide, but it's still very much in its infancy as a technology. Close to home, there's a project that's currently underway in the sort of Outer Moray Firth area. An old field is being repurposed for carbon capture and storage. It's called the Acorn project. But also across the North Sea in Norway, there's a project that's just starting for the massive Troll field to be used for CCS. And in England, there's the Humber CCS project, which is to make a coal power station, combine that with CCS to reduce the carbon footprint. So another massive plus as to why we should be using carbon capture and storage is actually because of the gas network in the UK. When you're creating CO2, one of the byproducts is hydrogen. And this is a fuel that we can use up to 20% in our gas network already. And so it just makes sense to integrate that as quickly as possible. And all that knowledge that has been gained by geoscientists in the oil industry is directly applicable within the carbon capture and storage scene. And so this is why we need, or one of the reasons we need geoscientists in the energy transition. So as you know, Outcrop stands for sustainability and for geology, sharing a love of the study of our Earth. And carbon capture and storage is a vital technology that depends on geologists and geoscientists, and it is required for a successful energy transition to allow our energy needs to be met by fossil fuels, however reducing the carbon footprint of those methods of energy production. Thanks for watching, hope that was helpful somewhat. And if you would like to support Outcrop, feel free to check out our website, outcrop.tmail.com. All our products are sustainably made, fair trade, and inspired by geology.